Hello everyone, welcome to the workshop which we organized just now. I'm László Szabó from the Regional Center for Energy Policy Research, and the aim we are here that we have a workshop where we would like to cover a very interesting topic which will cover the topic of decarbonized grids in the electricity sector. So that's a very challenging task, and let me welcome all the panelists. Mr. Paul Fox, British Ambassador to Hungary as well. I would like to thank the embassy as well for allowing and supporting us in putting together the program for this workshop. And we are very happy that we have very good speakers from Hungary and from the UK as well, who can present the case for the decarbonized grid plans and actions which were taken in the two countries. Actually, the way we arrived here was a very interesting one, just to share you some information, because of course we had some negotiation with the embassy that what are the crucial topics we have to cover. And it's not a surprise for me, and probably not for everyone, that this was the first topic which was selected, that the grid and grid-related issues which has to cover with these challenges that we have to decarbonize our economy by 2050, and we would like to achieve very demanding goals by 2030 as well, put enormous challenge to the grid developers, grid operators, and the users of the grid as well. So it was a nice selection, and I'm very happy that we were taking this topic on board. And what you have to see that it's really crucial for Hungary, what we learn, and if you are following the situation in Hungary, what happens that since last year we have this stop of new renewable development because the grid has reached its limitation, and the TSO and the government announced that we have to take a thorough examination that how can we improve the situation. And it's a pity, because what we can see at the same time that Hungary was developing in a pathway with a very dynamic increase in photovoltaic generation. So we saw that we were on the pathway to reach our targets, and suddenly this break or stop came. And it's very interesting that we would like to see that this break is a quite short period, and we can further develop the grid in the way that we can still reach the 2030 and 2050 goals, what we have and what we share with the European Union. And it's a very nice occasion that we have UK panelists here, so we can learn from the UK experience as well, because we think that you are well ahead of us in some sense, because what we learned from your policies and from your targets as well, that UK is not only targeting similarly to Hungary to have a 2050 decarbonized economy and a very demanding 2030 target, but you have an even more advanced target for 2025 and beyond, that you would like to see your network operated in a way that it can cope with decarbonized electricity system, so it can cope with longer period when the full system is decarbonized. So I think this information exchange and our target for the workshop is really nice, really challenging, and I'm very happy that we have very distinguished experts both from the UK and from Hungary who can share their thought and who can share their vision how to improve the situation, and we can see the next year's tasks and challenges which we have to fulfill. And thank you very much for your being here. And with this, I would like to give the floor to Paul Fox, the British Ambassador to Hungary, to give the opening speech for the workshop. And then after this, we turn to the distinguished speakers of the workshop. Thank you very much. Paul, the floor is yours.
Thank you very much, László, and I just want to say welcome to everyone online. It does take me back to the days of lockdown when we were grappling with technology in order to continue with business, but it's great that we're all online. It's great that we're able to talk about this important issue today. I mean, this is the first of a number of workshops that we at the British Embassy have designed with the Regional Energy Policy Research Centre at Kovács University. And I'd like to thank everybody who's been involved in organising this and everybody who is participating in it. Now, the focus is on energy transition, which is a key priority for the UK government, whether at home or in terms of its foreign policy. But let me start by explaining why energy transition and net zero are at the heart of UK government policy. We believe we now have a historic opportunity to accelerate our pathway to reach net zero emissions target by 2050. Fundamental changes have taken place in the past few years, with more than 90% of the world's GDP committed to net zero. So given this reality, last October, the UK government commissioned an independent review of our net zero strategy. The aim was to seize opportunities arising from an emerging economy, and the review involved business, central and local government, academia, and the public. It was carried out through all 4 nations of the United Kingdom. It heard from over 50 round tables and received submissions, about 1,800 submissions of evidence. It was the largest engagement exercise on net zero delivery in the UK, and the findings were published last month. These made clear that we need to do more and to move faster to achieve our net zero target, not only to safeguard the environment, but to be best placed to take advantage of the economic opportunities on offer. The main conclusions were, well, firstly, use infrastructure to unlock net zero by accelerating the implementation of the British Energy Security Strategy, by developing a cross-sectoral infrastructure strategy by 2025, and by reforming our approach to planning so that where locally supported, more solar and onshore wind can be developed more easily. Also, to create sustainable government structures for net zero by developing an overarching government financing strategy by the end of 2023, and by establishing an office for net zero delivery. We want to back businesses to go green by reviewing incentives for investment and protecting British industries from environmental undercutting, and by building skills needed for the transition by driving forward the Green Jobs Task Force. Also, encourage local action by reforming the planning system and backing at least one trailblazer net zero city. Increase transparency by expanding the government's public reporting on net zero by ramping up public information and developing a net zero charter mark. We want to deliver cleaner, cheaper, greener homes by legislating for future home standard and by adopting a 10-year mission to make heat pumps a widespread technology. Seek to capitalise on international leadership by conducting a strategic review on the UK's international climate leadership and introduce environmental and climate protections in future free trade agreements. And finally, set ourselves up for 2050 and beyond by ramping up our investment in research and development. I mean, there's a lot to digest here, and I'm sure you'll hear more about it in more detail as the day goes on. However, I'm sure you would agree that these recommendations are comprehensive. More importantly, they are applicable to most countries, not just the UK. Lord Stern, the author of a landmark study on the economics of climate change, has said the transition to a net zero economy is the growth opportunity of the 21st century. And the UK is well placed to benefit if it makes the right decisions. But our partners further afield can, I hope, learn from our experience. So I hope the discussions today support that aim and help build closer policy and business exchanges in energy transitions between our 2 countries. So thank you very much, and I hope it all goes well today, and thank you for inviting me to open this session.
Dear Paul, thank you very much for this very nice introduction, and really thank you very much for your full support for the whole period which we prepared for the workshop. So thanks for staying with us, and thanks for the introduction. Just maybe one more announcement, that this is a workshop which will cover the decarbonized grid, but in March 16th there will be a second session where we also cover another interesting topic when we are dealing with flexibility-related issues and the storage-related issues as well. So you are welcome to note this into your calendar. Before I give the floor to the 4 speakers which we have in the morning session, I would like to just make a few announcements. We have quite a nice audience here. We would like to ask them to use the chat functions. If you have any questions or answers which you would like to receive answer, use the question function there. And we will follow these questionnaires, and then we'll select those questions which you can answer after the presentation. The order will be that we have 4 presentations. I will introduce the presenters soon, and then we collect the questions for the end of this first 1.5 hours, and we ask the questions when we finish with the 4 presentations. Before giving the floor to Julian Leslie, Head of Networks and Chief Engineer Network and the National Grid at the ESO in the UK, just maybe 3 thoughts I would like to share with you. Why do we see that this is one of the most important challenges for Hungary and probably for most of Europe? That we have to deal with the decarbonized grid. We have to improve the grid in order to cope with the new challenges. Just 3 facts or 3 information. The first one, and the ambassador already told, is that it's really a huge investment challenge as well. We see huge numbers here. If you have a look at this Euroelectric publication for Hungary, it will be 3.5 billion euro spent on the networks in the next coming 8 to 10 years. Quite a huge challenge financial-wise. Second issue is that we see an issue here that regulation versus wire. Why do I say this? There are solutions which would improve the network conditions by putting more equipment, more investment into the field, but it will be very, very expensive, we see it. On the other hand, we see that some regulatory changes are needed in order to get other solutions which can reduce the cost of this transition, which can reduce the decarbonizing the grid solutions, which would be very interesting to hear about it. And the third issue, which is very challenging and very interesting, is that we see the changing role of the DSOs and the TSOs in this field. They have to cooperate much more. Their tasks and duties will be changing in the future, in a sense that DSOs will have some tasks which they had never had before, and TSOs will have to cooperate in that sense more closely with them. So these are the important challenges, and it would be very nice to hear your point of view on this. And thank you very much for your patience, because we are just using our time in that sense. I would like to give the floor to the first speaker, to Julian Leslie. And because we are working with networks, what happens is that unfortunately we cannot share the video of Julian Leslie. Just arrived. So we will do the presentation in a way that we try to follow your presentation. Please give me some feedback if you already see the presentation of Julian. Just 1 second, we try to share it. Just a second, it will arrive soon. Do you see it already?
Yeah.
And do you see it in full screen?
Yes.
Yes, so please, Julian, go ahead. Please tell us when we have to jump with the slides, and we'll try to follow you in that way.
Brilliant. Well, thank you, and thank you for the opportunity to speak this morning. So I'm Julian Leslie. I'm Head of Networks and the Chief Engineer at the Electricity System Operator here in Great Britain. What I'm going to do this morning is just give a very quick update as to where we are on sort of some of the technical challenges we've had to overcome to sort of meet our ambition of operating our grid system at zero carbon for a few hours in 2025 as a pathway then out to 2035, when we need to do 100% of the time across the full year. So if we can just go to the next slide, please. Just after that. Next slide, please. So just a reminder as to what our role is here in the UK. So we are a legally separate system operator, legally separate from the grid. So we don't own the wires, we don't own the generation, we don't own the demand, we don't buy and sell electricity. what we do is operate and balance the system on a second basis. We are very strong advocates of promotion, of competition. So whenever we bring anything new to the market, then we very much lead from the competition perspective where there's value for the consumer. We do make the network recommendations. So interesting to hear that Hungary needs to spend £3 billion. We published a report last April, and we have to spend last month £50 billion to connect 50 gigawatts of wind by 2030. Huge expense and huge investment in the network. All the connection agreements, I know that might be a question, how do you deal with the huge amount of connections which are coming through to the system? And then finally, we do all the charging and billing for the big suppliers and generators across the nation. So that's who we are. So on the next slide.
Julian, can we ask that you come closer to the microphone because we have some noise as well. So please go ahead.
The next slide, please. So why have we been so successful and how are we on this journey? I mean, as we heard at the top of the presentation, we have a clear and consistent government ambition over quite a sustained period. Yeah. So started with 15% of all of our generation had to be renewable by 2020. That target was met and in fact exceeded in 2020. All coal was to be closed by 2024. When you think in 2013, just 10 years ago, 66% of all of our energy came from coal. And here we are. If it wasn't for the war in Ukraine, the coal would have all closed by now in 2022. But we had to convert them for the wind that currently continue. We have new targets looking into the future, though, 100% zero carbon generation at the time by 2035, 50 gigawatts of offshore wind by 2030, of which we have 12 gigawatts today, so a big increase in 8 years. And then also 10 gigawatts of hydrogen electrolysis by 2030 also. We're really beginning to think about a whole energy system solution by converting electricity to other low carbon forms of fuel sources. And as mentioned earlier, that we set out in 2019 as the electricity system operator, that we would have an ambition to be able to operate our system at zero carbon in 2025. And I'll talk shortly about how we are progressing towards that target. So next slide, please. So where are we then? So as a decarbonised system, we are an islanded electrical system. So we have interconnections with Europe, but they're all HVDC. So it means that the synchronous network that we have here is islanded from the rest of Europe. And therefore we have some real challenges which mainland Europe doesn't have around frequency management and inertia. And what we've had to do is think very differently about where those sources of inertia come from and how we manage frequency as we lose the conventional fossil fuel generation with their large rotating turbines that provide with those inertia and frequency control. So but our plan therefore for 2025 was that for short periods of time, probably on a windy sunny Sunday afternoon, that the market will deliver us 100% at zero carbon solution, and we will be able to operate the system in that condition. And I guess if you look at the targets there in a little box, so earlier this year we had nearly 88% of zero carbon generation, and also the following day we had 67% share of wind generation. So what that means is on the 4th of January, we were able to look at what the 12% non-zero generation, why it was on the system, and make sure that our plans for 2025 would have negated the need for those particular 12% generation, so 5 or 6 units. We know now that the plans we've got in place that have been delivered in the next 12-18 months would negate the need for those 6 machines to be running. Therefore, we have huge confidence that if that same scenario arose in 2025, we would be operating this system here in GB at zero carbon for those few hours. So if we go to the next slide, so how have we made this happen? We've had to break down sort of the challenges into sort of 7 key areas. The frequencies I mentioned before, we're a small islanded electrical system. Therefore, small change in generation in or demand out has a big impact on our frequency. It wasn't a problem when you had lots of large rotating plants with lots of flexibility, that the frequency was straightforward to manage. As we've decarbonised, as we're closing the conventional power plant, we've had to think very differently. So what we're doing now, we've introduced something called dynamic containment, which is service provided by lithium-ion batteries. And what that means is that as the frequency moves from 50 Hertz, because there's a loss of generation input somewhere, then the dynamic containment service delivers all of its power within 1 second. We have 1,000 megawatts of batteries sat there in the market. They see the frequency, and we get 1,000 megawatts of generation effectively delivered to the system within a second. So that means we can operate the system at much lower levels of inertia. And therefore, the stability of the system, we can run much lighter. However, we still need something that provides inertia and short circuit infeed. So two very technical kind of aspects of the power system. And we've gone to market, we've defined our need, what is required, and the market has delivered innovative solutions. We are the first operator in the world that has procured grid-forming inverters on batteries to provide this short circuit. And what this means is that we can continue to operate the system safely and securely without the rotating plant of generation. For voltage, as the generation, certainly in GB, all of our wind is in the north. In Scotland, where there's very little demand, not very many people live up there, there's not a lot of industry up there. So all of that power needs to come south. We need to keep the volts high on the system when it's windy to keep the power transfer moving, but it also means there's a huge amount of network that when the wind isn't blowing, that is actually just acting as a huge capacitor and rising the volts in the system. So we need to find methods and ways to reduce those volts in the system and keep them in safe operating limits. And I guess one of the biggest challenges has been the thermal challenge. So we have wind in Scotland, all of our demand around London and the southeast. So we've got to move huge amounts of power for several hundred miles across the system. Finding ways to invest in the network, finding ways to get the planning and the consenting so that the network can be built in time has been a real challenge. And we have something called connect and manage in GB, which means that the generation can connect and then we manage the output through the market. So currently we're spending close on £1 billion per year on just managing the thermal constraints on the system. We have plans to build £50 billion worth of transmission network that avoids some of these constraint costs, but the planning, the consenting, and the public acceptance of this infrastructure is a challenge, and that makes the delivery of these projects really difficult and perhaps not in the same time that we'd want them to be. So all of those things are in place for 2025. As I showed earlier, we have huge confidence that if the market delivers us that zero carbon solution in 2025, then we have the tools, the techniques in order to manage the system. As we look out to 2035, though, there's two new aspects that come into play. The resource adequacy, so what is that energy mix that you need to ensure security of supply? And how do you use the demand flexibly so you can match the demand with the generation that you have? So if you look to 2035, that within day matching of generation and demand, I think with lithium-ion batteries, with people's electric vehicles, with an extension of what we did this winter in GB with a demand flexibility service where the consumers across all of Britain could participate in reducing their demand over the peak. So the concept of consumers moving and shifting their demand is now out there. It's something that we've practiced through this winter. In 2035, that needs to be much stronger, and the consumers will have hopefully black boxes in the homes that move the demand to when the generation is most and therefore cheapest and lowest carbon. So the within day flexibility, I believe we can manage in 2035. I think we will have the tools and the market mechanisms to do that. However, on the resource adequacy piece, the bit that we're missing currently in the GB is what you do when you have a week of no wind and very little sun in the summer, in the winter when it's pretty cold as well, and how do you ensure that you've got that security of supply? Is it met by a gas-fired power plant with carbon capture, usage and storage, or is it met by long-duration energy storage in compressed air, in salt caverns, in hydrogen electrolysis and stored hydrogen, or whatever that solution might be. So that's sort of the last piece of the jigsaw that's missing for 2035, and we're working very closely with government and other policymakers to understand what it is we need to do to get that over the line to sort of close out that gap. But everything else, I think in 2035, if it's windy and if it's sunny, we can manage 100% zero carbon generation. As I say, the challenging hours is just when we have no wind and no sun for a number of days. And then how do we have enough energy stored left in the system to manage that? And you'll be saying, but it says 7 challenges, but there's only 6 on the slide. The last one, which is system restoration. So what happens if you have the worst scenario and the whole system is in the dark? How do you restart? Traditionally, we'd have had a diesel engine at a coal-fired power station that would come online. It would get the coal mills running, get the power station up, and you can start to rebuild the network. Obviously, that option isn't available to us in a zero carbon system. So we are building the capability such that wind farms with a battery or wind farms with a flywheel or whatever, that they can have the technical capability to restart the system. So actually, we're going to be able to use renewables to restart the system following the worst scenario of a full system shutdown. So that is the last 7th challenge that we need to be able to manage in order to bring the system back. So anyway, so that was a very, very quick canter through everything that we're doing from more of a technical perspective, I guess, hopefully giving you a view as to where we are in the UK on this journey, and really sort of showing you the confidence that we will be able to run this system at 100% zero carbon for a few hours in 2025, that we are on track to do that. So I'm sure we can share these slides after, because on the next slide it's just got some links to the documentation of everything that we're doing in this space. So there's lots of good reading there for those that want to understand more about what it is that we are doing. So with that, I will hand back to László.
Thank you very much, Julian, for your very nice and very interesting presentation. So I think it's really nice to have. I hope the others heard you better. We had some problem at the beginning, but at the second half it became much better. So thank you very much for your presentation. Please stay with us, because there might be questions coming from the audience at the end of the session, so we might need you later on to answer some of these questions. And with this, I would like to give the floor to our second presenter, Márk Alföldy-Boruss, Deputy State Secretary at the Ministry of Energy. Thank you very much, Márk, for being available and sharing your view on this issue from the Hungarian side. You have to know that Márk is really the best person from the ministry to tell that what are the thinking and what are the current policies toward getting more and more decarbonized grid solutions into the Hungarian system as well. So please, Márk, the floor is yours. I heard that you would like to share as well some slides with us. No, we see it. Thank you very much. And I think I switched off my microphone because that helps the quality of yours. So please go ahead with the presentation, Márk.
Okay, thank you so much. Thank you first of all for the invitation and also for the welcoming words, László. And I would like to also welcome all the presenters and our audience. I would like to join to the thinking that nowadays we are in a historical opportunity. However, in terms of decarbonization, however, I would like to add that means also historical challenges when we are talking about the grid development and the grid operation. Can you see well this slide? I don't know whether it is mixed a bit or not.
Yeah, it mixed a bit, but I think
okay.
We can take it.
Okay, all of the colorful, nice pics then we're missing from that, but the words are there, so we can go on. So what is the the biggest challenge nowadays. Over the last year, we have experienced that that the energy trilemma came back to our daily work. So we have to work again on sustainability, affordability, and security of supply. However, over the last couple of years, 5 to 10 years, it seemed that we have a good equilibrium of that goals, but the last year unfortunately showed that this status quo has been upset, and the age of cheap energy is over. So we have the new situation, what requires a different approach, where the security of supply came to the first place. And in Hungary, our primary task is to reduce import dependence and exposure. And to this energy trilemma, we have a fourth element as well, the growing needs, and we have to serve somehow the rapidly growing industrial and another electricity needs as well. So despite this, we are not giving up on our climate policy commitments. I would like to summarize what are the goals. In Hungary, we have a very strong fundament on climate protection because it is embedded in an act. So we have an act on climate protection, but has 4 main goals: 40% decrease of GHG emissions by 2030 compared to 1990 level. We have a goal that in case of the final consumption will increase after 2030, then it should be supplied by solely decarbonized sources, while we would like to reach a 21% renewable share by 2030, and the strategic goal is to reach the net zero status by 2050 in Hungary. These are incorporated in the Act, and as an accommodation document, we have also the energy strategy and a national energy and climate plan, where we have also another goal to reach 90% decarbonized domestic electricity production by 2030. So these are the strategic goals, and how to meet these goals. We have currently 3 key milestones to be reached: reduction of natural gas demand, increasing of the share of alternative energy sources, and serving the growing demand for electricity and flexibility. The third one is the topic of the today's meeting, I guess. So what are the challenges here? I guess we have 4 challenges. The first challenge is the decentralized and decarbonized production, what is here in Hungary, and we are happy to have these possibilities both at nuclear and at photovoltaic side. However, we have to somehow manage also these energy sources. So here you can see that what is the context? The context is that the maximum gross peak system load in Hungary is about 7.5 gigawatt, while the photovoltaic generation has an extraordinary pace over the last couple of years. As you can here see at the right side, the existing already installed capacities of photovoltaics below the smaller size household sized ones, and on the upper side the commercial or industrial sized photovoltaic plants. Altogether altogether the installed capacity exceeds already 4 gigawatt compared to the 7.5 gigawatt maximum gross peak system of Hungary, system load of Hungary, and we have another tremendous number of capacities which are coming. As you can see here, we have 4.6 gigawatt photovoltaics under construction and 3.6 around gigawatt applicants who would like to join and produce electricity by 2030. I'm happy that Evelin Kish is also here from MAVIR, from the TSO, and she can then add some information to that or some updates on that numbers. But overall, the context is that the weather-dependent installed capacity exceeds peak system load shortly, which is a very big challenge, and networks and system operation and system operator has to keep pace with that photovoltaics trends. The challenge number 2 is that growing and decarbonized consumption need we have here in Hungary, based on 3 pillars: electrified reindustrialization, electrification of households and services, and electrification of transport sector. We have several common problems across EU and also with the UK, but I guess that this reindustrialization and the impact of reindustrialization on the electricity system is higher in Hungary compared to another member states or compared to the UK, because Hungary welcomes lots of battery plants and its connecting ecosystems, but already have an impact of 1.5 gigawatt peak load demand and up to 2.5 gigawatt peak load demand we can see here when we are talking about that newcomer electric intensive factories. Plus we have the let's say normal decarbonization of existing industry as well, where we see that the existing industrial players would like to and also should to change and switch from natural gas to another sources, and this switch is not only an energy source switch, but also technology switch. So instead of heat usage, lots of industrial players would like to change to electric technology as well. So reindustrialization with the newcomers and also with the existing industrial players is a very big challenge, and which is a very normal trend. We see that the households and services sector would like to be electrified as well. We see the shift from natural gas heating to electric ones, and we also see the growing cooling need in Hungary, which is not a luxury need of households, but a very normal need, and could be and can be also served only with the rapid electrification. And we have the currently lower electrification intensity in the transport sector, but in the 5 to 10 years period we count also on its increase. So overall, in the coming years, by 2030, we do see an approximately 50% electricity consumption growth in Hungary, which is a tremendous number, and we have to somehow keep the pace as well. Not only the networks, the system operation, but also when we are talking about power generation. This is a number, but is I guess extraordinary. The 50% increase in energy consumption by 2030. What is the third challenge? The finance. What is the context here? That the cost of conventional district system development usually increase tariffs, network tariffs. The traditional approach would cause, let's say, endless tariff increase, and the current remuneration system of network owners and operators drives primarily CapEx orientation. However, we can not meet the strategic and political goal of affordability when the endless tariff increase is embedded into the system. So here I would like to add a new point compared to Julian's presentation when he talked about engineering challenges. We have also in mind that this is not only an engineering challenges, but we have here in terms of the 50% electricity demand growth. But besides of engineering challenges, this is also a social, economical challenge of our countries. Because of the limitations of affordability. What is the situation? The situation is that Hungary can use lots of EU funds, but could ease in the capex pressure on the tariffs. However, the time frame for project implementation under the EU funds and EU fund umbrellas is really very tight. So this challenge of finance drives us to the thinking that the use of flexibility solutions is a must. So we have to find some alternatives as well to the conventional approaches of system developments, and one alternative could be the flexibility. So flexibility solutions is a must, and we will welcome the discussion of the TOTEX approach that was opened by the EU electricity market design reform. But because maybe the new or amended remuneration system of network operators would open also the possibilities and opportunities to have more flexibility solution in the grid. And the fourth and least challenge is the optimization. How to use the available measures we have. What are the main goals? We do have that the EU market design brought already the basics of newcomers in the electricity sector, newcomers as flexibility providers and so on. But we would like to and should have a common understanding within the country and within the industrial players about the potential advantages of these flexibility providers, namely the flexibility providers itself, using energy communities, also by using the potential flexibility supply of district heating systems, the CHP plants, aggregators, smart metering system, dynamic tariffs, limited connection contracts, and also one goal should be to have an overview of not used capacities to get back somehow these let's say free capacities to another players. And what is not listed here, but I would like to also mention that we still don't have a common understanding within the country about the potential advantages or the real place of batteries in the system, how to use and what goal to be reached with the use of batteries, and we also have still a debate about the advantages or benefits or cost problems. What is the balance of the presence of household-sized photovoltaics in terms of the network losses? Plus, we would like to have also a look on the dynamic network development possibilities as well. So here, I guess that these aspects will lead us to a general overview of the least cost approach, that maybe the TOTEX base or another approach could be easing somehow the income of flexibility measures. And after that overuse, we would like to set the new standards, which new standards could serve the affordability growing needs and sustainability and security of supply. So these are my thoughts for today's meetings, and I guess that the UK is ahead of us when we are talking about the use and usage of these flexibility measures, and I'm very keen on the experiences of UK players, and would like to thank you for your kind attention, and also wish a fruitful discussion for today's workshop. Thank you very much.
Thank you very much, Mark, for your presentation. I think these slides and what you have just mentioned, they are really giving a very nice coverage of the policy dimensions and the main dimensions which we are facing in that sense. I think it gives a nice background for the next two presentations, because from the general policy side, we go now to the more detailed engineering side, as you have mentioned. So thank you very much for being here, Mark. I hope you can stay with us a bit more if there are questions to you. I don't know if you will have time for that, so please, if you can stay with us, because there might be questions popping up later. And with this, I would like to give the floor to Péter Kovács, a strategic grid development leader at E.ON. And please, Péter, if you are here, share the slides with us, and then I give the floor to you for the next presentation. Péter, we see the slides. Thank you.
Okay, thank you very much. You see the slides in full screen? Okay.
Yes, it's okay.
Okay, thank you very much, and I would like to thank you for the invitation, and I would like to welcome all the audiences as well. My name is Péter Kovács, and I work for E.ON Power Network Strategy as a long-term planning operative leader. I would like to briefly present the challenges of rapidly growing distributed generations, which are mainly in PVs in Hungary. The rapid growth of small-scale household power plant, let's say rooftop PVs, is just as challenging as the integration of large PV parks. I would like to show you what steps we have taken and what we are still planning to take to deal with those challenges, whether it means technical solution or developments in grid regulation. In the first slide, or on the first slide, I would like to show the challenges. I think there's nothing new because Mr. Leslie said before 3 engineering challenges. I show almost the same in my presentation. Okay, beyond our previous expectation, households and the industrial actors try to cover their energy needs with solar systems. And more things that business model provided by PV parks is profitable in such an economic and regulatory environment. What does it mean in numbers related to E.ON network, which means 3 DSOs in Hungary, the whole Trans-Danubia, this is the western part of Hungary, and Budapest and its surroundings. The existing generation in this area, it's approximately 3 gigawatt, and that means 2 gigawatt intermittent generation. It's 300 megawatts wind and 1700 megawatts PVs. The amount of predicted power parks is approximately 2.5 gigawatt, and more than 90% of them are coming from PVs. Okay, this figure shows 2 typical periods used for long-term planning. That means year 2027. One is a winter evening period when PVs do not produce energy, but the consumption is high. And the other ones is a summer weekday early in the afternoon, where when there is a high PV production and the low consumption. On the picture, you can see the built-in capacity of the PVs in Hungary in 2027. It's more than, the prediction is more than 10 gigawatts. And the consumption, you can see, it's when the consumption is high and the load is high, it's more than 9.5 gigawatt. When it's low, it's about 6 gigawatts. That means if the PVs are product or have energy, Hungary have an export in energy because the load is low, and there is a lot of PV production. We have in that time more than 5.5 gigawatt export. This is not a use case in nowadays because Hungary is an importing country. You can see here when there is no PV production, we have to have an import about 4 gigawatts. What does it mean in the DSO side? When there is no PV production, the energy flow going to high voltage, going from high voltage level to the low voltage. But if there is a lot of PV production, the energy flows from the lower voltage to the higher voltage level. That means from the distribution system to the towards the transmission system. Okay, because the consumption and the distributed generation are not simultaneous, and as the result is that we have a problem in low voltage level and mid voltage level with maintaining the standard voltages, and in a high voltage level overloads can occur, as I show here. Also challenging to handle, as Mr. Alföldy-Boruss said, the high amount of predicted industrial consumers, which means additional 1 gigawatt load beyond the 4 gigawatt peak loads which have in the 3 E.ON DSOs. The expected number of e-cars by 2027 is about 74,000. Just for comparison, there are currently 47,000 e-cars in the world of Hungary. Of course, these affect the flow on low voltage and middle voltage level, but we have to take into account the growth of the small scale households PVs, the heat pumps, the residential consumptions, and the larger PVs. So we will have growing consumptions that will cause voltage volatility, that will cause changing direction of power flows. And as Mr. Alföldy-Boruss said before, the flexibility is a must. But for this, we have to extend the monitored network. We have to increase the volume of the data exchange. This means a need to improve the IT security also. There is also a need to improve the operational of the network and the increase of the utilization of the network. What we did so far and what measures are we still needed going forward? From a network point of view, it is necessary to strengthen the network with the traditional investments. That means construction of transformer stations and building or upgrading network lines also. To determine the necessary investment, we introduced a centralized long-term network development planning process led by MAVIR. We have also a new connection methodology for power plants for generators. But various obstacles can occur during the construction periods. For example, by simplifying permitting procedures or public procurement procedures, the period required for implementation could be used. Where possible, we also like to use innovative tools, but we are really in the beginning of this way. We have many pilots to gain experience about the tools and to see which tool can help us to find solution for the different challenges and where they can be used most effectively. The implementation of the smart network requires the development of monitoring systems, as I said before, and to increase the volume of the data exchange. The very first question regarding the development of flexibility markets is what products can be defined to solve the various problems which can be communicated to the market players. I think I can connect to here Mr. László, who said that as one of the 7 engineering challenges. If you excuse me, I won't go into the details, but different tools can be the solution depending on the voltage level, depending on the problem to be solved, and depending on the network users. What still needs to be done is to evaluate the completed pilots, carry out the existing ones, and learn the appropriate lessons and incorporate the tools into our normal operating models. We have a lot of colleagues who deal with this, who could deal with these pilots. We have a lot of efforts how to use these things to solve the problems or answer the challenges. What about the grid regulation? Just a short overview. From 2024, a flexible tariff will be introduced for those households who have smart meters. This will affect the evening period, and the expected effect is peak shaving. Also from 2024, there will be changes in metering calculation for households. Currently, there is a very favorable accounting system for households, which does not encourage the use of energy when it's generated. In practice, this means that they use the grid twice. Once when they generate the energy and don't consume it, and once when they consume, but the rooftop panels don't generate. I think they don't pay for either, or just a small small part of it. Today there is a restriction for new households PVs. The government introduced a temporary feed-in restrictions. The elimination of this restriction will be taken place at areas where the grid is able to connect a new request without any technical problem. Where there is a problem, it should be handled by the DSO. And we have generators. Also, what has been done related to them? As I said before, a new centralized connection procedure was taken place for generators led by MAVIR. I think the expected results of it to collaborate about the investments and how to react and what kind of investments need to be done to connect this new entity to the network. There are many aggregators on market. I think Ms. Kish will be say something about that. They mainly deal with power parks. I think there is some steps how to involve the consumers also to the balancing market. Procedures for demand side response, as I said, is in development phase, not only for MAVIR but for the DSO side as well. The solution related to energy communities follow the previous topics, perhaps a little behind, but they also have available state funds to realize their ideas. In summary, it can be said that E.ON's main goal is to prepare its network as quickly as possible to able to connect as many renewables energy sources as possible. I think the energy of the future is electricity. The most important task of the companies operating the networks is to adapt to the changing circumstances, to continue to prepare for this change with developments and take into account the needs of their customers and to support the domestic energy and the climate policy goals. I think we are just started that way. We did a lot of things. What we have to do is much more than before. So we will see what I wanted to say. We are open for discussion with the other DSOs, with the TSO, and with the governmental parties also. So thank you very much for your attention, and also wish have a nice day.
Thank you very much, Peter, for your presentation and for your thought. And I would like to call already the fourth presentation here. We are lucky that Evelin Kish, Head of Business Development Department at the MAVIR, at the Hungarian TSO, accepted the invitation. So we are very happy that Evelin, you are here with us. And I think it's a very nice occasion from step up from the DSO level to the TSO level. Challenge is an issue. So please, Evelin, if you are here with us, please share your presentation now, and then I will give you the floor on the screen. And we see the presentation as well. Thank you.
Welcome, everybody, and thank you very much for the opportunity to be here. Thank you very much for the invitation. I hope soon you will see my presentation, because it seems currently I have a bit of a technical issue, but let me please save some time in order to show you my presentation. First of all, thank you very much for being the fourth one today, because most of the presenters have already mentioned all the challenges, let's say, we have nowadays. I will try to show you how we are dealing with the challenges as, let's say, a daily issue, as a daily routine, from mainly the aspect of PV connections. Can you see my presentation, or it's still invisible?
We see it actually, Evelyn. Thanks. So you can go on with the slides. You see the first slide, but no, it disappeared.
I have some issue with my PowerPoint presentation. Please let me check it once again.
No problem, just please go ahead. But Evelyn, we have seen it before, so
now I hope you can see it.
Yeah, we see it now.
So,
yes.
can you see it now? Okay, perfect.
Yes.
So, sorry for the technical issues. So, altogether, what I would like to tell you today is a brief introduction of our challenges on daily routine, meaning one of the challenges we are having is the boom of renewable weather-dependent production. The reason why I would like to explain it today is to show you what kind of aspects can come with one simple issue, meaning renewables are coming and net zero carbon grid would like to be accomplished, but it has many aspects which are need to be discussed in more detail. So I will try to be brief, but I will try to also show you the aspects which come up with such a simple occasion. So this one sentence, boom of renewable weather-dependent production, has three sub-aspects in behind. One of them is the boom, which we had to handle somehow. We have to handle somehow in every day, in a daily routine. And behind this boom, there are many challenges. One of them was that by 2019, we had to face with a sudden increase of PV connection requests, meaning altogether until 2021, we were above 20 gigawatts of connection requests from photovoltaic producers. And it shouldn't be an issue, but it has some views why it was challenging and why it is still challenging for us. One of them is that these requests came simultaneously, and it means we need to develop the network simultaneously as well in several locations. Previously and earlier before, we had bigger power plant connection requests. We knew which location we need to develop. We knew how we have to develop, let's say, mainly the transmission system, the transmission network, but based on those requests which came and still come from photovoltaic power producers, we have to develop the network all together in several locations in the same time, in the same period of time. That's one of the reasons why it is quite challenging. And the other reason for it is that we still have to be able to secure the security of supply, the supply of consumers, while we have to develop the network of the whole Hungarian system. The other reason why this boom was quite strong and quite challenging is the externalities we have to face with, the volatility of prices, the volatility of markets. We have to develop a network while we operate in a European system, in a European market, in a European network, meaning we always have to be able to handle, to provide energy for consumers in the lowest price possible. And by this market-based operation, we always have to take care of sustainability, meaning it really matters how you develop the network, how you develop the whole system, because the main aim is to keep sustainability, keep the system in a secure operation during the whole period of time. And we also need to take care of the needs, since their main aim is the profitability, is to keep their business, meaning having 20,000 megawatts of PV connection needs in the system, while our consumption is not above 8,000 megawatts, but even less. It can pop up some questions: where will this production will go? And the reason why we have to ask this question is the weather dependency, since PV producers cannot always produce electricity when load appears. It has a really high weather dependency, meaning if the sun doesn't shine, PVs cannot provide electricity for consumers, even if Olympic Games wanted to be seen on TV in the evening or after sunset. It has to be somehow provided and ensured that there is electricity in the system, in the network, while there is a huge amount of weather-dependent production in the system. And that is the other reason why we have to stop a bit at the third aspect of it, its production. And the reason why I wanted to show you the issue of production as well is that, that on the one hand, we need to handle with distribution system operators together that it's not the same as it was before. We don't have one power plant with 1,000 megawatts, but we have 1,000 power plants with 1 megawatt of production. It really aims for a completely different way of operation, a completely different way of handling production and consumption in the same point of time. And from the production point of view, many of the speakers mentioned households, meaning we don't only see producers on the network, but what we see is less load in the networks, since it is a really high increase of household-based power plant production, meaning we see less load, but in behind it's more production. And the main challenge in behind it is that we don't see this production behind the consumers. There is no data which is available for us, in which way we cannot see a huge amount of capacity, a huge amount of PV production, which is weather dependent. This invisibility is really a big challenge which needs to be handled in the future. I wanted to show you some of the challenges from the boom of renewable weather dependent production, and in case of challenges are introduced, then comes some list of actions. And the way how we tried to handle, or let's say group, the actions we wanted to make in order to integrate this photovoltaic weather dependent production, we grouped those actions into 3 aspects: network integration, market integration, and system integration. From network integration point of view, in the last few years, what we did is creating a completely new capacity allocation process, where capacity allocation process means a coordinated process where transmission system operator and distribution system operators created a common process in order to handle all the connection needs in a coordinated way, in a transparent way, and in a predefined way, since all those connection requests are necessary to be handled in the same way, in the same procedure. And these connection requests are aimed to be handled in a really quick way as well. And that's why this capacity allocation process was introduced in 2022, last year, let's say. It was the first process where we initiated a public process which should have taken 6 months, and the aim is to keep the 6 months cyclic solution in order to provide every information for connection request owners in order to see what to do, when to do, and how to be able to connect to the network as quickly as possible. In order to keep these connection requests in a simple and in a coordinated way, we also introduced in 2021 a capacity guarantee, and based on these guarantees, we have valid connection requests which could be taken into consideration when we have to somehow calculate and simulate how we need to develop the network of the Hungarian system. The way how it meets with the yearly based network development plan is that we also deal with a yearly basis with a coordinated network development plan, meaning all the DSOs and the TSO have a common procedure which is made in a coordinated way. And in this network development plan, the aim is to be able to consider all the connection requests which were provided by the new producers in the system. Facing the 20,000 megawatt of connection requests in 2021, the decision was made we need to somehow validate how many megawatts is real request in behind. And in 2021, we initiated our first validation process when there was completely a new temporary solution. And then we introduced the capacity allocation process. This validation resulted altogether that this more than 20,000 megawatt of connection requests were 5,000 megawatts for real. So by 2021, we could validate all the connection requests, and we had a starting line, meaning we need to be able to connect as quickly as possible 5,000 megawatts of connection requests from photovoltaics into the Hungarian system. Then came 2022, and we had to realize there is one more validation process necessary, which is a still ongoing process, since based on the first period of validation, there was not all the processes or all the validation steps being able to be completed, and that's why we started a completely new validation process. And the aim in behind this one is to have the completely equal requirements defined for all the connection requests. This validation process will end by April this year, and hopefully this process will be the last one, and it will enable to follow these connection requests only through capacity allocation process. Currently, we have altogether approximately 9,000 megawatts of PV connection requests in the system, and this is the main aim to be able to connect these requests into the network as quickly as possible. However, what is really important to be seen that the Hungarian load is much lower than that, meaning this capacity will definitely generate export needs in the Hungarian system when the production of PVs is more than what the Hungarian needs define. From market integration point of view, what we tried to handle with during the last few years were some actions which enable proper let's say, operation of the Hungarian market and also of the European market. And from this point of view, during the last few years, we developed our Hungarian market in order to be able to provide our resolution in the products of the market, meaning we changed all our market, let's say, procedures to 15 minutes resolution in order to be able to schedule your production as punctually as possible. The other step we wanted to complete is to shorten the lead time in the market, and this requirement had to be handled in 2 steps. In the first step, we were able to handle it for market participants, and in the second step, we were able to handle it for producers and consumers as well, meaning there is a really brief lead time for all the producers and the consumers in order to be able to schedule and let's say plan their production or their consumption. And the aim is also to be as punctual as possible with the forecasts of the market participants. We try to handle with some developments, but further developments are also necessary, and that's why we have continuous market analysis, how market participants behave, act, and can, let's say, sell and buy their energy on the European market, on the Hungarian market as well. That's why we try to provide as much as possible really focused market analysis in order to be able to identify more and more integration steps. And one of these are the continuous analysis of our new coupled market, which is a flow-based day-ahead market, a European market where we hope that all the production and consumption can be sold and bought in order to find the balance of the system on the energy-only market. And what is also necessary to be mentioned here, that by these analyses, we also try to find and identify market-friendly developments, since we still have a feed-in tariff in our system, which in our point of view needs to be further developed in order to be able to a completely integrated element of the market, not only the Hungarian one, but also the European one. And last but not least, since based on the market, based on the network, there is a system which needs to work continuously in order to be able to secure the supply of consumers, I also would like to mention some of the actions which were made during the last few years, and some of the actions which are ongoing in order to be able to, let's say, complete the whole integration challenge of us. One of these were the, let's say, aggregation. From aggregation point of view, what we wanted to realize and what we wanted to complete is to provide every possibility for market participants to be able to participate in balancing market independently from the energy-only market, meaning being part of a balance group should not be a problem being part of any other aggregator. This was a really big challenge and a really big development in our system, which was completed during the last year, meaning we don't care if it is a consumer, if it is a photovoltaic producer or any other producer, or even an accumulator. Any kind of resources are more than welcome in the balancing market, since we are lack of resources, and such sources would be really beneficial in order to keep the balance of the system and keep the security of supply of the Hungarian system as well. The other step which we had to handle and we wanted to solve during the last year is to achieve better forecasts, not only for us, but also for the market participants. Based on this, during the last few years, we tried to handle with public forecasts available on our webpage, public forecasts available for all the market participants, and we've also initiated a new project where we try to handle with the invisible production of household power plants or PVs. And in this way, we can handle the increase of household PV capacity, since we have a forecast what is the amount which can suddenly appear as load and which we need to balance in the system immediately. We have a balancing market, which means this market also needs to be developed in order to be able to keep aggregated or single market participants. And in this way, we wanted to introduce an intraday procurement of balancing capacity and an hourly resolution of such products in order to be able to invite and involve PVs in this market as well, since at least in downward direction they can be an active and a beneficial participants of this service as well. And based on these two actions, which are planned to be completed during this year, we also introduced a new scheduling process, but it is strictly connected to balancing market, which is a close to real-time schedule. We call it a baseline, where all the producers can provide their real-time information on their planned schedule, which can be a more, let's say, effective information in order to see how many balancing capacity, and based on this, how many balancing energy offers, and in this way, how much balancing energy we have in the system in order to keep the balance in between production and consumption. Briefly, these are the actions which are already made and which are still planned to be made. But what is also important to mention, that such actions cannot be completed without a really intense IT development, a really intense network development, and a really intense data accomplishment, which are really big challenges in our system. But hopefully during this year we can take some action in order to achieve these all together as well. Thank you very much.
Thank you very much, Evelyn, for the very nice and very comprehensive presentation. From your last slide, we can see already that how busy you are at the TSO, so how many actions you have to cover in the operation. I'm just looking at the clock, and I just realized that we are using the time for the first session. So just to share you some information, we actually planned a 15 minutes break now, but let me use maybe 3-4 minutes for one or two questions which we got from the audience. Then we have a break and we start with the second session with the panel. The good news is that many of the presenters will stay on, so we can still continue with the questions to you. But let me use two direct questions from the audience, and maybe Evelyn and Julian, if you are still here, we can start with one of the questions which is quite interesting, and I would make it a bit more general than it was asked in the chat. That one question was concerning the renewables, that they are part of the problem. Of course, they cause this high volatility, intermittence, but on the other hand, they can be part of a solution as well. So can we use renewables, intermittent renewables, PV and wind generation, providing the solution as well, in that sense that they can participate at least in the downward direction, keeping the balance of the system. And the question is that maybe for Julian, whether you use this option in the UK already, and how do you see the problem and issue here in Evelin? How do you plan to go ahead with this type of solution? So Julian, what do you think about that?
Sure. So we have created something called power available. So that means that a wind farm or a solar farm can sort of say, well, if we weren't restricting our output, what would our power be? And that's allowed them to play in the frequency response market, both in the positive way and in the downward respect as well. So if you're a 100 megawatt wind farm, we might hold 20 megawatts of response. The power available signal says you're available for 100, but you're currently operating at 80 megawatts, and therefore there's a price for us to hold that response on the wind farm. And then when we need it, the wind farm can increase its power to 100 megawatts. So that's sort of where we are right now. So we absolutely need renewable generation to play in the frequency response markets, because we will only have renewable generation on the system along with the nuclear in the next 10 years. So they need to find a way to play in the market, and power available was a signal that we used in order to do that.
Thank you. Evelin, if you have anything to share on this, what are the plans in Hungary?
The answer is definitely yes. That's one of the reasons why we try to develop the procedures of balancing. So in downward direction, we also try to introduce PVs in the market, in the system. It's an ongoing, let's say, pre-qualification process with all the PVs which are able to provide such services. And for those PVs which cannot provide it directly, and one of the boundaries is the amount of their capacity, because above 1 megawatt is the amount which we can communicate with the power plants. So for those who are beyond 1 megawatt, aggregation is the best solution, because aggregators can aggregate all these resources which can be considered as balancing resources. I hope that all the PVs which are, let's say, able to provide such services will come into the system, will come into the market. What is really important to provide data, real-time data, which can be considered as an information to see how they are provide their capacities.
Thank you, Evelin. And maybe I just group two questions together, and because I see Mark is still with us, so maybe these two questions will be for you, Mark. The first question is that, is there a plan to introduce flexible tariffs in the near future, and if you see it as a solution for some of the issues we cover? And the second issue was, actually, it's not even a question. I think that we see that the development in Hungary is that we have lots of photovoltaic in the system. So we do not see too many. I mean, we have 330 megawatts of wind only. And the question was that why was this development? That I don't think it's quite difficult to answer, but maybe what we can answer is that, how do you see the future of wind generation in the Hungarian system? Whether you see some movement that we can have a bit higher level of wind generation in the near future. So, Mark, if you have any comment on these two issues, it would be nice.
Yes, okay, thank you so much. I guess based on the current legal framework, there is already the possibility for customers that they can ask for a flexible tariff or a dynamic tariff. So please do that, and let's see what the traders will answer for that. The legal basis is there. The second one is the wind. Yes, I guess that I can only reiterate the political level sayings regarding that there are still ongoing discussions within the government on the exact procedure, where to and how to make possible further wind installations, and we will in the coming weeks, I guess, already we will have already the decision, and then after that we will also communicate there. But as there is no final decision yet on governmental level, I cannot share further information about that procedure. Thank you so much.
Thank you very much, Mark, and thank you for staying with us. And if we still have 1 minute, maybe there will be one more question to Julian on the UK system. So there was one question concerning the PV and the wind development in the Great Britain. So the question is exactly which was asked is the following. Sorry, I just managed to close it and I have to come back to that. Just 1 second. Sorry. Just a second, because I managed to close it. Okay. So who is the UK planning managing the targeted 50 gigawatt of PV by 2030, plus the more than 300 gigawatts of wind in the Great Britain? Do you plan to rely on storage, hydrogen, or battery in that sense? So I don't know, Julian, if you have any comment or answer to this question.
So for 2030, there will still be the gas power plants on the system. So in 2030, even though we will have the 50 gigawatts of wind and umpteen number of gigawatts of solar, actually we will still be able to secure the system in 2030. As I mentioned earlier, the challenge comes in 2035. The UK government has consulted on what are the sort of solutions that meet that storage requirement to manage those intermittencies in 2035. Get conclusions what the market structure could be. But certainly my belief is that there'll be hydrogen stored, ready to come back and produce electricity. I think we will have compressed air in salt caverns, which are around the English coast, which again can be a store of energy. And then whatever sort of large-scale energy storage technologies become available in the next 10 years. But the important thing at the moment is that we need a policy direction from the UK government in order to give that investor certainty to bring these things to market. So it's not a problem for 2030, but as I said, it's the missing piece of the jigsaw for 2035.
Thank you very much, Julian. And sorry for that. I just see that the audience became very active in the last minutes. Maybe the ultimate question which I would like to ask, because I think that's an interesting one, that Evelin from the Hungarian TSO mentioned this problem, the non-visibility of the PV systems, which are the household side, for the system operator. Do you have the same issue in the UK that with the household installations of the small panels one, you don't have information that, okay, what is their production level? Does it cause any problem in the case of UK as well? You see it as an issue, or if you have solved already this, what was the solution for that?
So, I mean, as far as we're concerned, in the National System Control Centre, we don't see individuals' consumption, obviously. With our demand flexibility service product that we launched in the market this winter, we've ran several tests, and the suppliers, we've said to the suppliers, we need 100 megawatts, 200 megawatts. They then liaise with their consumers. The consumers say, yes, happy to play tomorrow. This is what I think I'm going to do. And then on aggregate, the suppliers have always delivered more than we asked for. So if we asked for 100, they've given us like 150 megawatts of response. So the consumers have been really engaged this winter in the activities, partly because it's a bit of fun, I think, for a couple of hours when it's a one-off, but also they save or get paid £2 or £3, £4 by doing that, depending on the reduction in demand that they have added. So we don't see the individual, but we do see the aggregated sort of impact of consumer action.
Thank you very much, and sorry for using part of the break here. So really thank you very much being available here. And let's follow a bit the program. So what I propose now is that we are at 10:41. So let's maybe have a bit shorter break, almost 10-minute one. And let's come back at 10:50 when we start the panel discussion. The good news is that most of the presenters will be here, so we can still go on with the questions as well. And the other good news is that we have Phil McNally with us from the University College of London, and he will manage and he will moderate the panel, and then I think it will be a very nice discussion which will continue to cover this topic. So thank you very much. Please If you still have questions, send it to us. If we have time, we'll try to answer it. If not, later on, we can still try to follow up with your question. Thank you very much, dear presenters, from your contribution. Let's have a 10 minutes break for coffee, and then we come back at 10:50 and continue with the discussion. Thank you very much. Hello, everyone. I'm just looking at the clock again, and I think we are just on time to start the second session of the today workshop. I just have a very limited role here because we have the opportunity that we have Phil McNally here from the University College of London. So thank you very much, Phil, for accepting the invitation. And actually, we are very grateful that you accepted the role that you will moderate the second part of the session, where with the previous presenters plus one new guest, you will have a nice panel discussion about the same topic. So with this, I would like just to give the floor to you, Phil, and then you just organize the panel as you planned and as you agreed with the others. So really, thank you very much for accepting an invitation, and we are looking for a fruitful discussion with the panelists. Thanks a lot.
Great, thank you very much, László. Just to check, you can hear me clearly?
Yeah, we hear you well, yes.
Great, brilliant. So welcome back, everyone. Good morning, and welcome back to this second session of this knowledge sharing event between the UK and Hungary. As László said, my name's Phil McNally, and I'm a research fellow at University College London. In terms of a bit of background, my research focuses mainly on electricity markets and the reforms that will be required to enable the sort of accelerated deployment and efficient deployment of low carbon and flexible technologies that are required to deliver the government's ambition of a net zero power system by 2035. I think firstly, I just want to thank colleagues at REC and the embassies for putting this event together. I think knowledge sharing and collaboration on these issues will be crucial through this transition, especially as we're embarking on this deep overhaul of our electricity and energy systems. I think inevitably we're going to come up against barriers and challenges, and so sharing the experiences and learnings from different nations will be really important in revealing different approaches and ways of thinking that will lead to quicker solutions, hopefully. So as László mentioned, this morning's session was more information focused with the presentations, and we had some great presentations on the challenges and ambitions in both the GB and Hungarian systems. And then the second session now is designed to provide a bit more room for discussion around these issues, and I'm glad to say that Evelin, Peter and Julian will join us again, and they'll be happy to answer any questions that you have from earlier and any questions that come to you throughout this session. So please do continue to enter your questions into the system, and I'll make sure to address as many of those as possible. But before we move to that open discussion, we've got one new panelist with us, Andrew Lever from the Carbon Trust in the UK. And Andrew will give a short presentation now on the role and value of flexibility in the GB system. So Andrew, it's great to have you with us. We can see you clearly, and I'll just ask you, there we go, we can see the presentation. So the floor is yours.
Perfect. Can you hear me? Okay, yeah, super. Yeah, well, thank you, Phil, for the introduction, and yeah, good morning, everyone. Very pleased to be here. I'm Andrew Lever. I'm a director at the Carbon Trust, and I head up our work on energy transition. The Carbon Trust is a mission-driven organisation. We are here to accelerate the move to a decarbonised future. We use our innovation, policy expertise, impartial, mission-driven status to do that, to accelerate that transition at speed and scale, working with both public and private sector stakeholders. So, yeah, if we could maybe just move on to the next slide, and I'll give a short introduction to the work we've done looking at flexibility. So this is a report that we completed about 18 months ago. It was set out to understand, as you can see, the role and value of flexibility in meeting Great Britain's 2050 net zero targets. And in actual fact, we took the analysis one step further to, if you like, burden the power system, the electricity system, with an additional 50 million tonnes of carbon reduction to counteract the hard to treat sectors in the UK, so aviation, etc. So we actually pushed this analysis to a negative 50 million tonnes target in 2050. And so we really wanted to understand, and looking across the whole energy system, so not just the power system, but also how do we decarbonize heat, transport, how do we use hydrogen in that net zero energy system. And to do that, you can see some of the logos around the outside of this slide. We convened a kind of collaborative cross-sector consortium to work with us on this across the power distribution networks, the gas distribution networks, energy suppliers, aggregators, solutions providers. And we also worked quite closely with the UK government and the various policy and regulatory teams in a steering role to make sure we're very keen that we wanted to ensure that this piece of work was useful, both from a policy setting and direction perspective, and also to industry to help understand fundamentally how flexibility could be incorporated into their own plans and activities. So just to say a little bit more, maybe onto the next slide around how we set about this this analysis. So of course, when you're looking at 2050, you quite often will look at scenarios, and that's exactly what we did. So you can see here we modelled effectively 3 different heating pathways of how Great Britain could decarbonise its heat sector. And these include, of course, electric heating with heat pumps, with hydrogen heating and boilers, and also a hybrid heating scenario, which included kind of heat pumps with a backup gas boiler. The reason we chose heating to kind of, if you like, move and form the basis of those different scenarios is because that we felt that heating and decarbonising heating is one of the most significant, has the most significant impact of how we shape the energy system, but it's also one of the maybe the more uncertain ways of how GB kind of does approach that, because it's a tricky challenge, as you may well know, to decarbonise heat to get to those net zero targets. So what we did was we basically modelled the role and the value of flexibility alongside those heating approaches, and it gave us a better understanding of the types of flexibility that's required and how that interacts with those systems, fundamentally, of course, to reach our net zero targets at lowest cost. So you can see here on the top right of this chart, we effectively picked up 5 different kind of broad categories of flexibility, and effectively looked at those scenarios with a high flexibility penetration, and then curtailed the modelling to reduce the amount of flexibility that was available on the system. And that allowed us to then understand the value that could bring, and looking at metrics like system cost, how that impacted system demand, the generation capacity that was required, and of course the emissions profile. There were a number of additional sensitivities that we took out, but I'll skip over these just in the interests of time. And maybe just to move on to the next slide, which gives you start to move into some more of the answers. So I appreciate that there's probably quite a lot here to take in, but if you think of those again, those 3 scenarios that we set out across heat decarbonisation, these 3 sets of columns basically articulate the cost of the GB energy system in 2050 without flexibility, and then kind of with flexibility. And our conclusion, of course, here is that, well, by investing in flexibility, we believe that we could save between 10 and 17 billion pounds per year in 2050 by adopting a more flexible approach. You will, of course, observe some differences across these charts anyway. You'll notice that both the hydrogen and the hybrid heating solution scenarios are overall lower cost, and that's because they have kind of inherent flexibility. A lot of the savings, and you'll notice, of course, from the central 2 columns, which is the most expensive, but also give the largest, one of the largest kind of savings, and that's the electricity heating scenario. And that's because there's a high baseline of cost. A lot of that electricity, of course, has to meet peak demand, and peak demand in winter periods. And that of course, requires kind of high backup generation investments and high network investments. But yeah, as you can see, all 3 scenarios, investing in additional flexibility reduces investment required. Those savings mainly come from avoided generation cost and build out, and of course network reinforcement and build out. And indeed, you can see that any one of these scenarios does have a significant cost and infrastructure impact. So, and in fact, we're looking at an energy system in the UK, an electricity system in the UK that is 2 to 3 times larger than the one we have today. And so this is regardless of which of these heating scenarios that we deploy. And that's important to understand, because quite often we think about flexibility as the ability to avoid investment in networks, but actually with electrification of transport, electrification of heat and fuel switching away from fossil, we fundamentally are in a system that is larger than the one we have today. So maybe I'll conscious of time, I just maybe can move on to the next slide, share the next kind of insight, and that's flexibility is delivered from multiple sources across the energy system. So what you can see here is both across what we would kind of traditionally say as kind of power system flexibility sources, so battery storage, demand side response, etc., interconnection, and of course then we have kind of heating system flexibility, which in large part is kind of thermal storage. And so what you can see here is, investing in multiple, of course, sources of flexibility means that we avoid kind of price shocks. It gives us more durability in the system. And indeed, we find a variety of flexibility sources deployed across all of these heating scenarios, rather than kind of a few dominant ones that are, if effective, the winners. And of course, you may also observe that a significant proportion of flexibility is embedded within the operation of heat or indeed transport. And that means that we're coupling our electricity with heating from demand, and it allows, of course, that shifting of demand between electric vehicles, for example, and appliances, and that gives us additional functionality. Demand side flexibility is a big deal, from kind of domestic, non-domestic, industrial, electric vehicle sources. We found that the value that brings to the system is around about £5 billion per year in 2050. So I guess it underpins the fact that those sources of flexibility that are associated and embedded within heating our homes or our businesses, or indeed different transport means, are actually very good sources and very low cost sources of energy and flexibility. We also found that a portfolio of flexibility, and you probably see here, this is not just there's not one dominant piece of technology here, but a portfolio of flexibility, of course, helps. It helps manage uncertainty, helps reduce cost. Yeah, while supply side forms of flexibility kind of compensate, for example, reduce deployment of DSR by putting deploying more batteries, for example, they can't replicate, of course, the value that some of the demand side response measures have inherently within them. The next slide, just again a kind of other insight, and this kind of underpins. This is, again, I'll give you a moment to absorb the charts, but we wanted to understand, and many of you, of course, will appreciate that a lot of the flexibility is inherently at the kind of low voltage levels. It's connected closer to demand, and we wanted to understand what does that mean, and we wanted to understand the benefits that the distribution and kind of network sees in deploying that flexibility across its regions. And of course, what our analysis found is that there is significant value that is returned back to the network, of course, by deploying flexibility, by avoiding the reinforcement costs and improving the operability. And that was around about £500 million, as you can see here. We looked at London as an example, as a region, to understand this more. But what we also found was that actually that flexibility, albeit that was locally connected, actually drove twice as much value for the national system in helping to help balance and provide services to the wider operation of the system. And so I guess you can take a couple of kind of insights from that. One is that, yeah, whilst deployed locally, that flexibility has a wider role to play, but it also underlines the fact that you may want to increase investment locally in distribution networks to unlock the additional value that flexibility can provide at a more system operation and kind of national level. So the last piece of kind of insight to kind of touch on, the last slide, we looked at, as well as painting this picture of 2050 to understand the value and the different roles that flexibility can play. We also wanted to understand is how can we deliver that? You know, what are some of the things to put in place, and what are some of the enablers, of course, to making this happen? So I appreciate that probably the chart on the left-hand side here is a little bit difficult to read, but it basically is an assessment around across the different flexibility sources, so from domestic demand response through to electric vehicles, to thermal storage, battery storage, to electrolysis, an assessment around the enablers, the business models, and the kind of also the kind of capability of the sector to deliver an assessment around, you know, where are we on this and what else needs to happen. And a number of kind of key, I guess, overarching conclusions were derived from this as well. And I guess the first of those, as you can see, is that the digitalization and the opening up of flexibility is really can only be enabled by, you know, greater real-time coordination, of course, across assets, and that requires you know, electric vehicle charging and vehicle to grid charging, thermal storage, all working together to minimize and work together to optimize the system during periods of stress. That, of course, those assets often sit across different levels of the energy system and across different vectors and across different ownership boundaries. So it really needs a lot of connectivity between these and understanding that's data, but it's also how efficiently we can get these assets to coordinate and talk to each other. Secondly, of course, is that we need an evolving regulatory environment. Of course, our policy and environment and regulatory environment always feel as if they're in continual evolution, but you know, we are fundamentally moving away from a system that is more centralized to one that is decentralized, and you know, allowing the market signals to come through that reflect some of the system benefits that we see across generation, across networks, the carbon savings, the security benefits. You know, all of these need to be stacked up to ensure that the signals are correct in the market to incentivize and to promote you know, these range of flexible solutions. Consumer engagement, of course, is really important, partly, of course, and obviously because a lot of the flexibility sits within the transport system through EVs or within heating solutions in offices and premises. And indeed, kind of, you know, linked to that, and one of the key aspects, and certainly in my experience, we often find that flexibility is very much seen as a bit of an add-on to you know, an infrastructure project or you know, a proposition. I think what we would see is that embedding kind of flexibility from the start and including it within and embedding it within products and solutions and propositions is really important, because that means that you know, thermal storage and district heating, when that is being planned, heat pumps in buildings, of course, smart charging for EVs, all put in the enabling factors to allowing that flexibility to be accessed. And of course, what all that needs is the last point, unsurprisingly, is that continued innovation in business models, innovation in the technology, you know, demand side response, battery thermal storage, EV flexibility. This is about, you know, cost-effective integration, engaging consumers on the way, and you know, innovation that can demonstrate this at scale to really understand the complexity that goes with all of this. We would, of course, say that there's more to be done there. So I think I'm probably just about out of time, or even over time, but I hope that's given some food for thought and some useful context for the discussion. So yeah, hand back to you, Phil. Thank you.
Thank you very much, Andrew. Really interesting presentation, and I think the focus on flexibility is key. just looking at the UK, I think to date, obviously a lot of the focus has been around sort of the build out of renewable capacity, and rightly so, I think. But then you start to hit a certain tipping point, and there's a lot of talk around flexibility, but maybe less research that's putting sort of the numbers on the benefits that will bring to the system. And I think that is key for really focusing politicians' minds on accelerating some of the policy reforms that are needed to bring the flexible technologies forward. So we'll open to audience Q&As now. We'll have more of an open discussion through till around 10:50, I think, before we hand back to László for the closing. So we've got 40 minutes of sort of open question and answers. So I'd encourage the audience to enter any questions you've got from Andrew's presentation into the system and any of the other presentations from earlier this morning. I'll also invite Evelin, Julian and Peter to rejoin us on camera when you can. Andrew, I just had, while everyone's joining us again, I had a few quick questions from that presentation. So I think there was a slide there where you had some figures showing that the flexibility could lead to, I think it was between 10 and 15 billion of savings per year in 2050. So really significant savings. I might have missed it, but was there an idea in there of the scale of investment that would be needed in those flexibility assets, so we could get an idea of sort of the return on investment that we're looking at here?
It's a good question, Phil. Yeah, we didn't necessarily. So all of our assumptions, I guess, are in the report in terms of the costs of the technology and the deployment. Of course, those are all inputs into the analysis and the modelling, which was I didn't mention also was done by Imperial College in London with their whole systems kind of integrated model. And indeed, I think the last slide gave you an indication of the build-out rates of some of those technologies into the gigawatts, and we are talking gigawatts even in some of those demand-side response levels. And the model, if you like, is a perfect view of the world. It is saying, all things being equal, without any policy costs or without any subsidies, taking the baseline of the cost of the system, then how do you get to the lowest cost ultimately for consumers, of course. But I think, I think to directly answer the question, we didn't put in it wasn't so much a view of how do you make the business models work for these, but more so, if you had total control, these are all the assets that you would deploy, because those fundamentally give you the lowest cost outcome in 2050. How you then interpret that into the commercial reality of those propositions, I guess, it comes down to how we implement that. And I mentioned how that how the regulation policy side kind of needs to help with that. You've seen those with feed-in tariffs in the past, etc.
Great, thanks, Andrew. So I think Peter will be joining us again. He's having some technical issues. I'm not sure if Julian will be joining us again, but just another quick question, Andrew, on one of the slides in there. So I think there was a slide that was showing sort of the flexibility from both power system flexibility and heating system flexibility. And I think I noticed in there wasn't much of a role for hydrogen in there. Was that sort of, do you not see a role for hydrogen, or was it just maybe that specific chart?
It was that specific chart. So we did have hydrogen. Actually, hydrogen was deployed in all of the scenarios. What we found with hydrogen was it is a very well. We saw in all of the scenarios, regardless of the heating kind of source, that hydrogen was deployed and was used for industry. But also as a source of soaking up excess generation in summer periods where you have lots of wind and solar, which is in excess, and that's where electrolysis came into play. So, and we did see actually both an electrolytic hydrogen as well as steam methane reformation, and that derived from gas, albeit with CCS. Deployed within the 2050 scenario. Maybe just to add a quick point, I didn't mention it, but it's a really fascinating piece. We had 150 gigawatts of offshore wind in the system in 2050. That's what we had to cap the model Otherwise, it would have gone on and on and on to deploy more. And fundamentally, of course, you have, when you're trying to get to net zero, renewables plays a big part within the system. And of course, that brings its own challenges from integration. And so hydrogen, in that perspective, was used extensively over the summer months to effectively kind of soak up that generation to then store and deploy, you know, in later time periods. So there was a, I didn't touch on it so much, but yeah, there was quite a role for hydrogen within all of the scenarios that we looked at.
Great. Yeah, I think that leads on nicely to sort of the next question. You know, if we're talking sort of that scale of offshore wind, and the UK has got a target 50 gigawatts of offshore wind by 2030. The scale of infrastructure that's going to be coming onto the system, you know, is mind-blowing. In the next sort of, I think, out to 2035 in the UK for a net zero power system, we're looking at something on the order of 200 gigawatts of low carbon power and flexible, you know, capacity that's needed. Evelin, you mentioned in your presentation sort of the TSO is being flooded with requests to join the system, and I know that it's a similar story in the UK as well, where there's sort of lengthening queues for grid connections because, you know, I guess the system operators have never dealt with this amount of capacity trying to come onto the system. And I was wondering maybe if you could give us Evelin, a bit of more detail around sort of the scale of connection requests you're getting and how maybe you're dealing with those at the moment, and any sort of changes that the TSO is looking to in future to deal with more and more connection requests.
You mean if we see a bit further than the currently existing requests, or yeah, what the big question is, there is a load which you would like to deal with in a Hungarian level and in a European level, and what we see is that renewables are coming into the network, coming into the system, but the big PV issue is that they produce always in the same time, meaning we have no difference in time. We cannot ask or at least let's say motivate them to produce energy in a different point in time in the western and in the eastern part of Europe. They have the same peak in the same period of time, and that will be the big issue, meaning we need to somehow see on European level how much of photovoltaic capacity can be considered in the same point in time in the system. Otherwise, we need to find some other solution to, let's say, keep this energy for a later point in time. And that's why storage is coming into all of our thoughts in order to at least shift this energy, let's say, in intraday level. What we have a challenge with is that we have a lot of requests in the same point in time, and we cannot explicitly keep the velocity of these needs. And that's why we somehow need to, let's say, schedule their connection and somehow provide them enough information to see how the whole European network and how the whole European system evolves from the aspect of PVs. Otherwise, let's say we blindly develop the whole system.
Yeah, thanks, Evelin. Yeah, I think that's sort of an element of system planning is needed, isn't it? Yep. Because, you know, if we, as you say, if you just sort of allow the development of PV and other technologies unplanned in different parts of the system, you're really going to introduce operational challenges for the system operators. So I'd encourage the audience to keep bringing the questions in. So I've got one now, which is around sort of the collaboration, the communication between TSOs and DSOs. So naturally, as we're sort of progressing on this transition, and we've got more and more intermittent renewable power coming onto the system, there's going to be a lot more requirement for flexibility in the system, as Andrew set out. And there's also going to need to be a lot more actions taken to manage and balance the system. So there's likely going to be a bigger need for collaboration and communication between the TSOs and the DSOs, I imagine. So Peter and Evelin, maybe you can give us a bit of an idea in Hungary of how that communication works between the TSO and the DSO, and any sort of future plans for formalizing better communications.
Okay, I'm sorry, I just come back because I have some technical problem. So what is about the communication? I think it's an ongoing topic because we have communications in about the high voltage level, about the system planning, about the long-term planning, and I think what will be needed to communicate the lower voltage and what happened in the lower voltages, because more and more participants of the balancing market will be connected to the middle voltage or the low voltage level, and will communicate with the TSO via aggregators. And if TSO use them to system balance or frequency balance or something like that, we had to know what will be the effect then of the middle voltage and the high voltage level. So I think these communication will be necessary on one hand. On the other hand, what Evelin said before, the TSO have to know what happened in the middle voltage and the low voltage level. And also we have to know that, for example, we have no metering about the households PVs. We have metering about the households, but only just the balance. We don't know the load. We don't know the exact rooftop panels generations. We just know the balance of the households, and that is, I think, a big lack of the metering of the data, and I don't know how to solve it, how we'll deal with it, but I think we have to go forward about to have data about the exact productions, exact consumptions, also in the households and in the industrial side as well.
Thanks, Peter. Evelin, is there anything you want to add to that?
Yeah, maybe just quickly. Yeah, let's say repeating what Peter said. We have ancillary services in order to keep the network in secure operation and keep the system in secure operation. Without all these, we cannot deal with the security of supply. And yes, the big challenge is that we have the same resources for dealing with both issues, meaning this decentralized production will cause for all of us in Europe or in the world that DSOs and TSOs have to use the same resources for different kind of purposes, meaning not only the parties have to communicate with each other, the solutions have to be somehow coordinated. We need to see what are the priorities, we need to see what are the resources we have. That's why we need the data, which was previously mentioned. And what is maybe also important, all these issues need to be handled in real time. So without IT, there will be no solution. Even if we call each other, even if we try to somehow communicate with each other, we have to identify what IT-based coordinated solution can solve such issues.
Yeah, thanks, Evelin. I think that's a key point there, isn't it, around the sort of digitalization, you know, the increasing amount of data that we have on the system here. I think, you know, there's a huge role for digitalization in the future of the system and increasing the efficiency. I think before we spoke about, you know, if we increase the efficiency in the use of the existing system, we're not going to need to invest as much in new capacity and new wires in the system, and that digitalization is key. In the UK, we have this energy digitalization task force, which is sort of running a program to really dig down into the steps that need to be taken to really unlock this potential for digitalization. Andrew, I wonder whether you might be able to add a little bit more on the how data and digitalization can play a part in delivering a flexible system.
Yeah, I mean, I think some points have already been touched on. We're dealing with many, or will be dealing with many more assets on the system. We've talked about heat pumps, we've talked about electric vehicles. Underlines the importance of smart meters and the continued rollout of those, but also how that data and information is shared. One thought that was going through my head was there's a program coordinated with the distribution networks in the UK called the Open Networks program, which there are 6, I think, different distribution network operators in the UK, and they have over the last years been increasing their participation and for contracting for flexibility kind of at that local level, and instead of, as you say, Phil, some of the more traditional forms of reinforcement. And the kind of key aspects of that program are, one, kind of standardization and making it easier for aggregators and flexibility providers to provide services to the network operator. Transparency, of course, is really important, and data provides that. I think that's with the evidence and facts and information, you're making the right decisions. And then the last point is around coordination, which I think touches back on that TSO and DSO kind of coordination point, where there are premise rules in the UK that are trying to kind of identify where that stack of services, and avoiding the bizarre situation where maybe the DNO wants a particular service which is contrary to the service that the system operator needs. For example, if there's a thermal constraint somewhere, system operator wants you to turn down, but the DNO may well have another issue on the network which is giving an equal and opposite signal. So I think it just underpins that with so many more assets that we expect to be on the system, and therefore the flows of energy being much more variable and uncertain to an extent, it just that data point and the digitalization infrastructure is just an essential part of that future system. So yeah, really, really important.
Yeah, definitely. And I think there's an interesting moment in the UK market, especially there's the government's recently been consulting on reforms to the electricity market arrangements for the future system. And one of the reforms being considered is the introduction potentially of locational pricing. So at the moment in the UK, we just apply one national price to electricity. Everyone pays the same price regardless of where you are in the system. But the government is considering whether we should be shifting to more either a zonal pricing system where different zones in the country pay a different price according to, if they're close to offshore wind, cheap power in the north of Scotland, or maybe paying more if they're in a centre of high demand. And then another level again is a shift to nodal pricing. So different nodes, thousands of nodes across the country might pay different prices according to the network availability and the renewable generation availability in the region. And it feels like if we're going to shift to a nodal locational pricing system, then digitalization and data is going to be pretty important in that future. I'll just go to a question now from Gabor in the audience. So they're asking, is there any capacity payment for demand side flexibility in the GB markets to support aggregators entering the different markets? So this is an interesting one. I think it'd be great if we had Julian with us still, but unfortunately we've lost him, and I'm not sure if he's able to join us back. But he was talking earlier on about the demand flexibility service, so the product that National Grid recently introduced. So this is quite a real-time product, so offering payment to consumers to turn down their power usage at critical moments in the system when maybe there's peak demand but not as much power. So the UK has been trialing that over this winter a few times, and it seems to have worked well. But this is more around capacity. So it's a well-timed question, Gabor, because we've just had the T-4 capacity market auction results in the UK in the last few days. And I think to answer your question, demand-side response is able to get capacity payments. So I think it was around 14% of the capacity payments that were contracted out by government for 2025-26. 14% of those were to DSR, and then for the next period, 26 to 27, again, 15% of the payments went to demand-side flexibility. So, so I think that's really positive development in the capacity market. There was quite a long period of sort of consultations to enable demand-side flexibility to get access to those auctions. But to give an idea of scale, so batteries in the same auction were getting roughly the same amount, slightly more percentage of contracts. So demand-side flexibility does play quite an important role. Evelin, Peter, I don't know if you want to add anything from the Hungarian perspective on the sort of role of demand-side flexibility and the support that it can receive.
Yeah, it wasn't part of my presentation since it was focusing on PVs, but it's actually also an ongoing development in the Hungarian system, meaning we had several forums and discussion with consumers if they are available, if they are able, if they are capable of joining, let's say, a new market segment, which is strictly for demand side response, but not on, let's say, not based on price level, but based on your pre-qualified capacities, meaning these demand resources should be or would be part of our already existing AFRR or MFRR markets. So what we are dealing with now is to introduce, let's say, a 2-year-long segment where demand can join balancing market on a specific product. And by these 2 years, the aim is to somehow help them to join the already existing automatic or manual FRR market. We really think there is a possibility and there is an amount of capacity which could participate in the original balancing market. But it's also important to mention that there is a need to help them to understand it, to help them to, let's say, technically be available for it, and yeah, somehow to see the business in it. It's really a challenging part to show them how to deal with capacity prices and how to deal with being available for such services, and in the way of activation, what to do, how to do it. There is a lack of understanding, or let's say lack of common understanding in the services, meaning there is plenty of time to educate our consumers to it, but it's also really important to see what they can provide, meaning what their capabilities as well. Otherwise, we cannot involve them in the market. So it's an ongoing development. I hope we will finish it in this year and we can introduce this new service. And the aim is to somehow create a market, create, let's say, a service without any other restrictions.
Okay, I just can repeat Evelin again. So we have several steps forward how to involve the resident consumers, the distributed storage to the flexibility market. What kind of problem can be solved with it? So we have a pilot right about it. I think we have some results during this year, how to communicate them, how to involve them, how to finance them, how to integrate our systems about these flexibility devices. So we have a lot of things to do. We will have a lot of discussion with the TSO, with the consumers, with the market participants as well. Yeah.
Thanks, Peter. Yeah, really useful updates. I think there was a key point in there, Evelyn. I think you mentioned around sort of the maybe lack of understanding and knowledge of this potential out there, and it feels like, especially in sort of organizations that have a higher demand, you need an energy expert who's up to date with the latest developments in all of these organizations, so they're able to sort of access the benefits and the potential of these DSR products, and also actually respond properly. So really interesting. Julian, it's great to have you back with us. I wonder whether, so this question was really around whether there's capacity payments for demand side flexibility. So we've established that there are, but I wonder if you just wanted to add anything on sort of the role that you see. You've spoken already about the demand flexibility service, but maybe from a capacity mechanism perspective, the role that you see DSR playing at the moment and maybe in the future of the system.
Sure. I mean, from a capacity point of view, we've had something for many, many years in GB called triads, and you get a thing in the market that happens, something called triad avoidance, because your annual charges were set on the power that you consume over the 3 sort of peaks over the winter, separated by 2 weeks or something. It's quite a complex process. However, that was distorting the market, so the triads have sort of disappeared for this coming winter. We had them still for this winter, and we got around about just over 1 gigawatt of triad avoidance by people trying to reduce their consumption over the peak, which obviously means then you need less megawatts for the peak, and therefore we need less in the capacity mechanism. As we move forward, though, what we want to be able to do, I think, is have a more market-driven sort of demand side response, demand side flexibility products, both for industry and for domestic consumers. So this winter, the DFS demand flexibility service product was open to domestic consumers and industrial users as well. We got about 250 megawatts, I think, of domestic consumer response, which is huge. It's well over 1 million customers. But we think that we can grow this service to around about 1 gigawatt from domestic, and then possibly another gigawatt or more for industrial users on top of that. And obviously, once you get to a position where you can understand and predict and forecast what response you're going to get, then it means that you need to buy less capacity in the capacity mechanism, because your peak demand is managed by reducing the demand of heavy usage and heavy consumers over that period of time. So I think we'll look back on the winter of 2022-23 in the UK and say, oh, do you remember when we first did that very broad brush demand flexibility service? And look at us now, where we've got 10-15 million consumers engaged, we've got access to 20 million electric vehicles, managing when they charge and when they discharge, etc., etc. So I think we've sort of cracked the initial stages of it, but there's a long way to go before this becomes mainstream and we have multiple people sort of buying into it that we can forecast, and we'll therefore get confidence on what our peak demand is going to be into the future.
Thanks, Julian. Really interesting overview, and yeah, hopefully we can look back sort of with nostalgia on this winter as a sort of a first step. So I'm just going back to one of the questions from the audience. So Gabor, it's quite a technical question, and I think probably Julian, it's probably most relevant to you. So the question is, how do you handle the sub-metering request of aggregators in the GB market? Are there technical requirements to allow different accuracy category for sub-meters used at household flexible appliances compared to meter of the whole household demand? Is this a critical issue for aggregators on DSR?
So it's a really interesting question, because normally all of our products and services in the market have to have high accuracy metering, so we know exactly what is going on. I'm not quite sure where we landed on the conclusion here, but we did do some work for, if you looked at 1 million data points, actually if they're all a little bit inaccurate, some would be positive, some would be negative. Actually in aggregate over across 1 million devices, does it net out to be as accurate as anything else you might need to operate the system? And I think the conclusion to all of that was, yes, that's fine. I can't remember what we've done in terms of sort of communicating that to the market. But certainly we have aggregators playing in the market now with quite some significant volume production. So I'm assuming they found a way around that sort of high accuracy metering challenge that we have. But yeah, it's not my area. It's more in the markets area than the technical side. So I'm not fully up to speed with where we are with that. But it was an interesting question at the time. I'm only guessing that we've managed to find a way through it because we have so many people now participating through aggregators.
Thanks, Julian. So I think we've got about 10 minutes left for this session just before we hand back over to László to close. So final warning for the audience to get your questions in if you want them to get answered. So we only have around 10 minutes left. So I'll move to one that's a bit more of a general question now. So maybe everyone can sort of chip in with a quick answer, but this one's just sort of generally, how should distribution network development plans be prepared, sort of looking to the future, and how can they be financed? So maybe examples from both the UK and Hungary. Peter, I might start with you on this one, if that's okay.
Yes, of course. How to plan the network? We have a joint network development plan with MAVIR, with the Hungarian DSO on high voltage level. It's a yearly procedure. We forecast all the production, all the consumptions for 5, 10, 15 years forward or ahead. And we after that we calculate the network and try to find the problems and try to find some solution, which is a technical solution. Let's say building transformer stations, building lines. Because for my side is a big question how to include or involve the flexibility or this kind of device to the long-term planning. So first of all we have to have experience about these solutions, and after that, I think after that can we after we can to include to the long-term planning, as well as in the lower level. But in the lower level, in middle voltage level and low voltage level, the process is almost the same. Try to predict the load, try to predict the production, and try to find the hot points in the network, and try to find a solution for the problems, for the challenging things. How to get money for that? That was the other questions. I think it's an ongoing questions with the DSO, with the government, with the national regulatory agency, how to deal with the amount of the rising prices or the rising money questions. I think we have to find all the resources like the tariffs, like the EU fundings, like the national fundings. I don't know the answer. I'm not an ecological man. I'm a technician, so I don't know the answer yet. But I think it's a long discussion. As I remember, Mr. Alföldy-Boruss mentioned that we have to find other solutions about CAPEX and TOTEX questions. So I think these discussions is on the way. I don't know the details. I don't know if they have result yet. But I think everybody's aims to maintain a good and sustainable network, and have to deal with all the questions coming to or arising about the distributed generations, about the growing loads and the industrial side also.
Thank you, Peter. Andrew, Julian, maybe you want to comment on sort of the UK experience around, if we focus on the finance maybe for a bit, so the regulatory regime that allows distribution network operators to invest in upgrades to the system, and yeah, any comments on how that works and improvements that could be made potentially, and learnings and lessons that are sort of positive from the experience?
I think obviously I'm a transmission system operator, not distribution. So, but I think, the distribution network operators here in the UK, they have a flexibility first as sort of their strategy. So before investments are made, that they go to market and say, actually, are there devices, storage, flexible solar, flexible demand that can actually avoid the need for network reinforcement, and then there's a cost benefit assessment done, which is pretty much what we do at the transmission level. We look at options in the market, look at the cost of reinforcement, do a cost benefit assessment, and either trigger the reinforcement or create a market solution. So the DNOs in GB are heading in that direction, and with the development of the DSO, distribution system operator, I'd expect that flexibility market on the distribution system just to grow. They're just about to start their new regulatory price control, which is the next 5 years, which starts on the 1st of April, ED2. So each of them are putting their plans for network investment. The other big thing that's just changed in the UK is that the network reinforcements, if you were a connectee, you paid for a lot of those deeper reinforcements in the grid. That has just changed. So now if you're a connectee, you have very shallow infrastructure payments to be made to facilitate your connection, and the rest is socialized. So I think how the DNOs think about those investments, how they trigger them, and how they go through their price control is something they'll be looking at very keenly, I am sure.
Maybe just to build on that a little bit, I guess more from a kind of planning and development perspective of longer term. The National Grid ESO have their future energy scenarios, of course, which give a view of how the UK or GB could evolve in various different futures. The distribution network operators have their own kind of versions of those, and they take a look at what they think is the potential is for connections, etc., going forward as well, and demand changes. And a related point, one I guess new emerging approach in the UK is to develop what are called local area energy plans. Many of the cities and bigger cities have set themselves their own net zero targets by 2030 even, and a lot of the local authorities now have their own, municipalities have their own kind of plans, or want to put their own plans in place around how they effectively decarbonize their own areas. And of course, when you do that and you look at the estate that they have and they're responsible for, undoubtedly it comes back to energy and demand, and the DNOs are kind of connected, or should be connected into those respective plans as well. So I think we are moving into this world where that decentralized move and having the electrification of demand through heating and transport, it's the greater collaboration and insight and working with those stakeholders, I think, is going to become much more important as we go forward. And broadly speaking, a lot of the network operators have set their own maps that you can look on the websites in terms of where there's connectability and over and the opposite. And I think they have become more sophisticated, perhaps, and more transparent around where the network is, and how where they need to plan for the future. So there's a few externalities that I think are increasingly kind of playing a role within within those future network plans as well.
Yeah, thanks, Andrew. I think that visibility of the different developments in different areas that will be undertaken as we transition is key, and that flexibility first sort of motto and approach will be key, specifically because, as you showed in your presentation, Andrew, that the scale of savings that can be achieved by making sure we embed flexibility and the most of that is through avoided infrastructure build out in other parts of the system. So we've got 10 minutes left. I'll leave a few minutes at the end for László to sign off, but maybe one last question, which is probably mainly aimed at Julian and Evelin as the TSOs. So Julian, you mentioned maybe we'd look back at this winter, and the UK's experiences with the DFS, but we had a really interesting experience at the start of COVID back in 2020, where obviously demand fell a lot, and we sort of got a glimpse into the future of the system where very high penetrations of renewables faced certain stresses on the system, but also gave great learning opportunity. And maybe I just wonder whether Julian and Evelin might want to talk a bit about some of the learnings that the TSOs got from that experience at the start of COVID, and how it's informed your thinking since then.
Sure. I think from our perspective, we were worried at the time that there was too much renewable generation and not enough demand, and we didn't have the flexibility. So we very rapidly moved to create a downward flexibility market where we had over 4 gigawatts of embedded generation sign up to that. But again, it's a very manual process. We had to notify the providers the day ahead that they were going to switch down on their output between certain hours the following day. So a bit like the demand flexibility service, a very manual, email-driven process. But again, it sets out the criteria and sort of the principles by which these embedded generation can participate in a national market for national benefit. So that ODFM service we did at the beginning of COVID, plus the demand flexibility service we've just delivered this winter, we've learned now in both directions how you get embedded demand and embedded generation to participate in a market that's providing national benefit. So the next stage for us really is to automate some of that stuff, really bring it into the market, because both those products were outside the market, really bring those into the market so it becomes an everyday tool that is available to this control engineers to make those choices as they optimize the operation and running of the network. So I think what the COVID showed us that we can run the system at very low levels. I think there's much more storage on the system right now as well, so you'd expect that minimum demand growth would actually start to grow again, because you would assume in times of low demand, high renewable output, that the price is low, if not negative, and therefore the storage devices will be maximizing their filling. And again, with more and more electric vehicles on the system, with more and more smart tariffs, then again, you would expect that minimum demand. We may never see that minimum demand ever again, because there's more flexible demand that will actually fill the troughs. So we never get to the levels that we got to in the COVID world.
Yeah, we also deal with such stuff, but in a lot smaller scale. Let's say what our big issues and challenges now is, to involve all the PVs, all the demand which is available in balancing market. In the meantime, seeing how demand changes, how the behavior of consumers create a completely different figure in the consumption of the Hungarian network, Hungarian system, which also creates new challenges. So it's a long way. We don't have too much time. We have to prepare for all those issues which were previously mentioned in order to keep up with those challenges.
Thanks, Evelin. Peter, Andrew, I don't know if you want to add anything from what you saw in that period as well.
I think Julian's covered it. I think COVID was an extraordinary period, and for demand, and particularly over the summer months. But I think, as I mentioned in my presentation, we do see, jumping forward into 20, 30, 40, 50, demand is very much bigger than it is today for the reasons that we've touched upon. So yeah, I think just underlines what we've already been saying around flexibility and flexibility first being more of the a lower cost option fundamentally to get there. So but yeah, yeah, it's interesting times going forward, but yeah, there's lots to do to get there.
For my side, it was interesting to hear that the flexibility first and then the network development, because I don't know exactly which is the cheaper in Hungary right now. So I think this is one question we have to answer before we use the flexibility. It is really cheaper than build lines, build transformer stations or not. It is beneficial or not. So I think it's not the first step, but the step in this way, and we have to rethink about it.
Yeah, thanks, Peter. I think that's the key challenge with this transition in general. Is the balancing of these different priorities and different approaches in different areas. In some places, flexibility might be the solution, and others, new build transmission or distribution lines might be the solution. So anyway, I think that brings us to a close for the second session. I'll hand back over to László, and I'll just thank all the panelists for a really interesting discussion and the audience for the questions. And yeah, I think that's it from us at panel 2, and I'll hand back over to László.
Thank you very much, Phil, for the very interesting panel discussion. So it was really nice to follow, and thanks for all the panelists as well. I mean, thank you very much, Evelin, to stay with us, Julian, Peter, and Andrew as well, sharing your view on this very interesting and very key questions which we had in the panel. Just a few words. What my takeaways are is that probably the UK partners learned a lot that. Sometimes we have a feeling that in Hungary we are suffering a bit more than other countries. I mean, we have some additional challenges, which I would list here, that we have some issues with the funding, which comes from the source that sometimes it's very difficult to make foundations through the tariff system. That's one issue. The second issue was that this one-sided development, what we see in Hungary, very dynamic and deep, dynamic and very quick development of photovoltaic, but one-sided because we don't have any additional new capacities coming into the system that contributes as well. Then what we have in that system as well, and we see in the new strategy of Hungary, is that we are forcing quite a quick development of demand at the same time. So really this 50% number, which was mentioned by Mark from the ministry as well, that in the next 8 years we really see huge impact on the electricity and power demand. That's an additional challenge what we see here, and you have to see, and you probably see it now, that the balancing market and the way it is organized, and because of the fact that mostly flexibility is provided by gas-fired plant, it's quite an expensive solution here in Hungary compared to the other countries. So these are the extras which we still have to cover, but it was very interesting to see that what type of solutions you were picking up and utilizing in the UK as well. And of course we see, and I think it's quite nice to see that the Hungarian TSO and DSO, they are really considering these options, the variety of options, not only to cover the technical solutions, so not only thinking in wires and lines and transformation system, but these other softer solutions as well has to be considered. Of course, you are right that we always have to measure that which are the right tools at which place. So concerning the 3 questions I had before, financing we covered, that's really nice. The second issue, which was that regulation, regulatory impacts, or investing in the network, which is a solution. I'm really glad to hear, and we always tend to forget it. It's not only regulation or grid, but you always mention, and it's we always have to remind ourselves market-based solutions, so we have to leave some issues to market participants if possible. Sometimes you have a feeling that in Hungary, sometimes it is a bit more difficult. And the third issue, which I mentioned in the introduction, is that DSO and TSO cooperation and the changing role of these system operation tasks. We heard a lot about that, and then we still have to continue here. So I hope you found the workshop useful as well, and I hope the audience as well. From the many questions we received, I think it was quite useful for them. Some technical information that we made the recording of the workshop, which will be available for the audience as well. And then one more issue is that we have some of the presentation already, so if we get the permission from the presenters, we would like to share it with the audience as well. But we will have this emailing after the workshop. So really thank you very much for the presentation, and really thanks for the British Embassy as well for providing the support and the opportunity for this workshop. And the last information which I would like to share with you, that don't forget that in 3 weeks' time we have that additional workshop, and we are going to more detail in that sense that we will cover the storage related issues and demand side response related issues. So it will be on the 16th of March. Please note in your calendar if you haven't done it so. And really thank you very much for your contribution here. And just looking at the clock, we were very good and efficient in that one. So we can go for our deserved lunch as well. So thank you very much for your participation. Thank you very much, Pierre, for taking this difficult duty of organizing the panel as well. So thanks a lot. We'll see you next time. Let's hope we can collaborate in the future as well. Thanks a lot. Bye-bye.
Thank you very much. Bye.
Bye-bye.